We've been talking quite a bit how robotics are a pretty small world. Everybody out here knows each other, but drones are kind of, at this point, an even smaller part of that world. You guys are pretty intimately familiar with one another's work at this point.
Yeah, I was just saying behind stage, when I was a grad student, we used drones from Jan's company, Ascending Technologies, to do a lot of the research that we were doing, and Andreas and I bumped into each other plenty of times years ago.
We're actually seeing a lot more of that. You know, we've had the opportunity over the past couple months to travel around to MIT and Carnegie Mellon, a lot of these amazing robotics schools, and it seems like drones are becoming a more and more important part of robotics research. Are you guys seeing that as well?
Absolutely, yes. I think actually drones have been already a very important part for many years, but of course, since they get increasingly more popular from a consumer perspective, of course, even more people are looking into building, make a scene, what can I do with it, what research can I do with it, and of course, especially from the compute perspective, the onboard computers on these drones get more powerful, we get better cameras, better sensors, specialized for the drones from the weight perspective mainly and from an integration perspective. So no bulky connectors, no metal shields around it, so you can actually put them on drones and fly them, so everything gets more exciting.
In a sense, it's kind of the most accessible robotics platform out there right now, right? I mean, these are pretty widespread among consumers, so if you're running a research facility, these are the easiest pieces of robotics to get your hands on.
Yeah, and it's interesting because even 5 or 10 years ago, that was definitely not the case, but we've seen so many of the developments that Jan mentioned create the system, and from an educational perspective, as an engineer, it's a really great system. It's the intersection of mechanical engineering and aerospace and electrical engineering and now machine learning. So it brings together a ton of technologies into one platform.
So what's happened exactly over the past 10 years? We've gotten from a point where it's this hobbyist curiosity to my parents are asking me about drones on a pretty regular basis. What kind of perfect storm had to take place to get us to where we are now?
Yeah, I think first of all, we have the economics trickling down from smartphones, right? Yeah. In terms of sensors and reliability of
smartphones.
Yeah. So I think that was a big deal. And then we had this DIY movement with DIY drones in around 2009, 10, 11, right? That created basically a technological backbone for people to be able to experiment in the technology. And on top of that, we had like the first forays into the commercial space via DJI and others who created this massive awareness. And I think they fundamentally tapped into this, there's an innate sort of excitement in anything that is flying, right? And these machines are pretty magical. So they have like 4 moving parts for the most part, right? And they can sort of do things that flying machines are not supposed to be able to do, right? So I think that created basically the backbone for user adoption and a lot of excitement in the space. And then, of course, anyone can map forward to that. In my mind, we're probably in the Atari years, or we were in the Atari years of that industry, and now we're moving into the sort of PC sort of years where we're going to see all these commercial applications built on that platform.
That's actually something I wanted to get to. That brings up an interesting point. I mean, you guys feel like we're right around that same spot when we compare drones to home computers, or when we compare drones to the state of the internet? Where are we on that timeline?
I think we're starting to see drones now tackle real commercial applications. So a lot of the work we do at Airware is for construction, mining, aggregate sites, where we're taking drone data, integrating that with other types of data, and then deriving analytics from it. And this is something that is now either saving businesses money or making them more efficient. So I feel like we've started to turn the corner with commercial drones, where these are starting to make an impact on businesses.
Is the hobbyist and home drone space, is that largely having a positive impact on industrial drones?
Absolutely, yes. I would say that's so. And maybe in addition to your question, what brings drones really forward now, I think the drones are very, very accessible, working in a very accessible space. So if you have a moving robot or a diving robot, underwater robot, you have a very obstructed environment. And drones, we can let drones free in the air, and with GPS and knowing a position already, we can stabilize them. And this brings us to scenarios where, for example, we had Intel do swarm flights with up to 500 robots in the air. It's basically unthinkable of in a driving robot right now, even autonomous cars. There's in so cluttered environments, and in air, everything is a lot easier once it flies, of course.
It's really important that we had that step because, 5, 10 years ago, when you mentioned drones to people, they would be thinking about, military attacks.
The D word.
Yeah, exactly. And to move from a state where you're thinking about, Afghanistan to Intel flying 500 drones in the sky, it's nice that we've got a little bit of middle ground there, right? It's nice that we didn't go straight from attack drones into having 500 drones above the Super Bowl.
Yeah, exactly. So I think especially our shooting stars drone swarm is something where the drones connect in a much friendlier way with the public. Mm-hmm. Then the public doesn't know about the commercial applications so much and how valuable they are. But if they see basically a new kind of fireworks outside, this is something which everybody understands and grasps. Of course, in reality, the commercial drones are the one key driver for the drone industry, and most likely the area where most of the valuable money will be made and where the most valuable applications are. And I mean, if you imagine rope climbers don't have to climb anymore at all, and you can collect right now all informations, and maybe later you can even maybe manipulate from drones what the rope climbers currently do. So there's a lot of things to come where you can really add value in these spaces.
So is the exponential growth of drones in the consumer space, is that having a direct impact on drones in industrial applications?
I think it absolutely is. The thing that consumer products have at their advantage is that they have tens of thousands or millions of essentially beta testers for the technology. So after a few years, the consumer drone products have become extremely robust and reliable, basically through trial and error and good design. Mm-hmm. And that's fed directly into the commercial market, where for many of the commercial applications now, you can pretty much directly use a consumer drone to capture the data that you want.
So it seems like one of the big hurdles that your companies have in terms of actually deploying these for industrial applications is a lot of regulatory red tape, and for good reason. Obviously, we want somebody to be monitoring what's flying through the air. As far as FAA regulations as they compare to other countries, where is the US right now?
Yeah, I think internationally we're seeing an effort to try and figure this out, right? Yeah. And nobody, I think, really knows the answer yet. What is the balance between, the standards that need to be introduced and met by different companies? And if those are very, very high, then, we won't see a lot of innovation in the space, and we won't see a lot of business models being tried out and iterated on. So what is the balance between like classic aerospace and sort of, free access, basically? My view is that there are certain sort of countries which are like at the forefront of that experimentation. My company, Matternet, has been, I think, the first company in the world to be authorized for full logistics operations beyond line of sight over people in cities in Switzerland. The reason why that happens is because the aviation authorities there are very sort of forward-looking, and they're trying to figure out how to really set up the right framework. We also participate with them in an international committee called JARUS, a work group there that's trying to figure out what the regulatory framework would look like. And the FAA is part of that as well. And what we're hearing from them is that they're also concerned around these two issues, right? Beyond visual line of sight, when you need to basically figure out how to deal with air risk. See and avoid other aircraft is one of the classics of demands. And the other is ground risk, right? So how are you making sure that when you're flying over people who are unsheltered, which in FAA's definition, I believe, includes people in cars, how are you making sure that you're not putting them in danger? And everything for a flying robot, everything from the build quality of the assembly to the software systems, how do you vet those things, and how do you make sure that you meet the adequate level of safety, I think, is the big challenge.
This is something we see on our end a lot when we're dealing with patent and trademark offices. A lot of times these governmental bodies aren't really up to speed with the technologies that they're actually regulating. Has that changed at all with the FAA over the last couple of years? It seems like they're working with all of your companies a little bit more directly now.
Yeah, they've come a long way in the past few years. So they just released fairly comprehensive regulation for within line of sight operations for small UAS. Now it doesn't include things like beyond line of sight, but they are catching up. They have now a UAS gateway, which is where it's a cloud-based thing where I can go online and request an airspace exemption. This is one of the more difficult things to do with the current regulations. So if I want to operate in or near an airport, sometimes I can get an instantaneous yes on that operation. Still, a way to go for the more comprehensive things like beyond line of sight for logistics or delivery, but they've come a long way, and as have many of the other countries in the world.
Is there a sense that we might be one really big, unfortunate incident away from all of that being turned back? I mean, if, God forbid, a drone should collide with a commercial airliner, for example, is that going to set back the clock a decade?
It would for sure be a very, very bad situation for the whole drone industry on the one side. On the other side, of course, given the state of the technology where we are right now, and that we've actually I think the industry has shown a tremendous amount of flight hours already. I think we are beyond the point where we can say, hey, we have no idea about the safety of drones. We definitely have a good idea of the safety of drones. And the biggest factor is, as in general aviation, always is the pilot actually. So if a pilot flies next to the airport and flies into an airliner, that's extremely unfortunate and should have been prevented, but it's actually against the law as of today, and it has been in every country, every Western country I know of. So I think in this case, people still would see that the benefit drones give in many applications is so huge that we maybe would rethink regulation again, or rethink how to maybe actually enforce regulation better. I think there's the bigger lever which you could use, but I don't think they would shut down the container industry.
I think the economic benefit is quite obvious it's obvious to entrepreneurs, that's why we're here, but it's quite obvious also to the people who form politics, right? So I think the political process is informed by that. I know for a fact, certain sort of top-down initiatives that have taken place in Europe and also here in the US, right? Because a country like the US cannot stay behind in this huge revolution that is about to happen with autonomous vehicles, right? And drones is one part of it. And of course, the destination and the destiny of those machines are to be behaving like robots, right? So autonomously, and they need to be trusted, and they need to have the right security and safety systems in place. So I think that the economic benefit and the upside is so tremendous, and we're now on a race to actually make it happen, and a lot of regulators understand that.
So how far out is that revolution? How long is it going to take until we get to a point where these are really being? Obviously, we're seeing some applications. We've talked about real estate developers who are using it for surveying and some data collection, things like that. But when do we actually get to the point that all of you are talking about? When do we get to a point where industrial drones are something that's truly mainstream, that's something that are just kind of a part of our lives?
I think it's something that kind of sneaks up on you. So I think the way that it will probably roll out is, you look out your window and there will be an insurance claims adjuster, and instead of climbing on the roof, he's using a drone. Like that might happen next month. And then, the next day, not only are there ground robots driving around in the warehouse, but there are also drones doing inventory. I think this is one of those things where maybe if you pause for a second and look, it may seem like everything has changed, but I think the technology is going to slowly work its way into everyday life, and it started certainly with drones.
So are there any major hurdles, aside from some of this regulation that we're seeing, are there any major hurdles to actually hitting that inflection point?
So I would say there are two big points where we definitely have to innovate a lot more and bring technology forward. One is automation. It seems from a consumer point of view, the drones fly so nicely and I can program waypoints, but I think that's not the level of automation you need to get to a large-scale application. And the second point is the data which is generated by the drones is huge. We generate a couple gigabytes per flight, and this data is a huge number crunching task. It's a huge task of transmitting the data from the drone to your servers, and this basically end-to-end solution from the whole data workflow, data capturing process, to processing the data, to basically generate a one-pager PDF what's broken on the asset you're inspecting. That's something where we'll see a lot more innovation and a lot more optimization happening.
I think in addition to that, we need to continue sort of educating the public about the benefits, right? So as someone who's in drone delivery, right, I live in the Valley. Even in this very technologically sort of progressive place, I can't see a scenario where, my neighbor, receives a delivery at 11 p.m. and I'm happy with it, right? I call it the Google Glass problem of technology, right? I mean, you are using it and you think it's cool, everybody else thinks it's not so cool, right? So I think it's really important to basically design the right path into, scale applications. When it comes to drone delivery, for instance, we think that most of the applications will be in the background. You won't even notice them. You'll just basically experience the benefit of them. And slowly, as the technology gets better, quieter, whatever better means, right? In each one of the verticals, we'll see it coming closer and closer to the user.
So let's talk about the next step. All of the really major applications that we're seeing right now come down to, again, surveying, data collection. It's really easy to equip a drone with a camera. So when do we get to a point when drones are actually servicing products? When do we get to a point when drones are doing something beyond actually just collecting?
Again, I would see that incrementally happening.
Yeah.
I think the larger breakthrough, I would expect more in a 3 to 5 year time frame. But there are certain applications where you can do that right now. For example, surveying is already a task in different scenarios where you can come to this solution now. And then other tasks is a little more difficult, but we'll get there pretty soon.
We'll be driven, this is maybe a silly answer. We'll be driven by the market. So, we spend at Airware, which is a commercial drone company, we spend a lot of time, working with customers to find ROI, to find areas where drones are actually useful to their business. And that's, it's surprising how much time you actually spend on that, as opposed to the technological development, which is still happening. But at least in our experience, much of the work has been in how do we make this technology useful for people and businesses. And so I think as that is explored in more depth, I think we'll start to see the applications sort of form themselves.
So it's not about having a solution in search of a problem. It's actually about dealing with all of these different clients individually, seeing what their needs are, and then attempting to address that with your technology.
So, and there are technological limitations. I mean, their drones are not perfectly autonomous devices right now, especially in unstructured environments or indoors. But I think the basic technology is there and has been for a few years in order for companies to start applying it to business use cases.
We discussed this a little bit before, but the 500 drone shows that Intel is putting on, these really impressive spectacles. The Super Bowl last year with Lady Gaga was a big one, and then in October, Intel put on this amazing light show with 500 drones all flying together. Obviously, spectacle is a really big part of that. Yep. Part of that is really trying to help warm people to the technology, to show them that drones can be warm and fuzzy, happy things. But what is the main goal of a big show like that from Intel's perspective?
So I think first of all, it's entertainment. So, we've been working with Disney. We did shows in Disney, in Orlando, Disney World, in Disney Springs for about, I think, 1.5 months, twice a day. So it was enrolled in entertainment there. We will bring it to Olympia. There was a big announcement from Intel as well. So the Olympic Committee is now an official partner with Intel, and we'll bring all kinds of technologies from VR to drones to Olympia as well. To the Olympics as well. And this is the first step of it, and eventually, hopefully, we have enough technology there and enough technology development to maybe replace fireworks. I would love to see a 4th of July drone show here in Boston at some point. The other part of it, of course, is the technology which is behind controlling multiple drones with one pilot or one laptop in this case, is something which, of course, would make sense in some applications elsewhere. If you, for example, search for a person in a forest, it's much faster if you search with 100 small drones with a little thermal camera, and it's technically possible. And if you know how to divide this mission and how to work collaboratively, that could be very powerful as well. So we're basically preparing this also with this technology.
As a roboticist, it's really cool to see on the sort of social level, you see things being done with drones like that. And I think it's inspiring to young people, and they might see that and say, flying robots are pretty cool, and that might get, I think that's going to drive interest in science, technology, engineering, math. And so that's another, I think, social benefit to seeing displays like that.
So, but there are actually practical applications for having 500 drones flying at the same time?
I'm not sure if it's always 500, but I think there are definitely practical applications for tens of drones for sure.
Yeah.
And in Matternet is exactly one very big scenario where you could see that for delivery drones as well. There you might most likely have 500, but not on one place, but
that does seem to be one
over
of the
the
sticking points, is
DIY,
how to get all of these, all the applications that we've seen out in the world right now are kind of one lone drone flying at a time, but if we can get them to work in tandem, that would be really useful for both of your applications.
Yeah, and we're already doing that. So, the whole concept behind Matternet and the reason why it's called Matternet is because you have this network, right, for transporting matter, and it's decentralized, and you have these different sort of agents that are transporting packages between different locations. And they're not coordinated as tightly as, a 500 sort of drone demo, but they are coordinated from a central entity, which is your dispatch entity, right? So you basically have a system that gets requests of what needs to be transported from where to where, and then calls a drone in, and the drone takes the package, and all of that stuff is done fully autonomously. And we have to be able to scale this type of system to, I don't know, thousands of drones covering sort of this sort of area where we are now, in order to be able to bring sort of real benefit and real impact into delivery, right?
We've been talking quite a bit about commercial applications and industrial applications, but far and away, some of the coolest demos that I've seen have been for rural and other underserved areas. We're seeing a lot of drones being deployed in developing nations. And I'm just kind of curious, and we can kind of go down the row and end on this, but what are your individual companies doing to really harness this technology to serve underserved areas?
So we started Matternet on this premise that one day this technology will be a leapfrogging technology. And countries that never have the capital to invest in roads and don't have that infrastructure will be able to use that technology to leapfrog. And of course, the playbook came directly from what we saw happening in mobile, right? So, within 10, 15 years, we saw a complete leapfrog there by technology. Now, so we started the company by sort of doing a lot of, all of our work was humanitarian. So we've done missions in Bhutan, Papua New Guinea, with UNICEF in Malawi, Doctors Without Borders, and the World Health Organization. And we basically understood what it will take to solve this problem. And now we're on the arc of solving that problem. So, my dream and our, I think, collective dream at Matternet is that within the next, let's say, 5 to 7 years, you may be anywhere in the world. We will be able to ship you 2 crates, with one base station each, one logistics station each, and one with a drone. And you'll just take them out, connect them, and you will be able to have a transportation system right there, out of the box, right? And we see that sort of dream happening with consumer drones today. And we believe we absolutely want to get it to that level where, it's a dependable sort of industrial level robotic system.
And in some of the insurance applications, catastrophe response is a big area of interest, not only for the business, but also for humanitarian reasons, where after a large event,
like a Katrina, for example.
Yeah, drones can really quickly survey the area, determine where first responders need to be, and then after that, provide more comprehensive information for insurance adjustment and get people's lives back on track a little bit faster.
Jan?
Yeah. So through the past 10 years of drone commercial applications I've done with Ascent Technologies before we joined Intel, we've done a lot of different type of applications where we helped first responders, or for example, we had one example, it's ISAR is called, it's a medical institution. They send doctors to catastrophic events, and they take a drone just for getting an overview of what's happening and where to put their tent, where are the most crashed buildings after an earthquake, for example. And we've always helped in these scenarios as well, for example, in an earthquake in Italy, where we sent down drones to do that. We also had a research project about nuclear disaster handling with drones, which is also very interesting. And lately with Intel, for example, we supported research on whales with Ocean Alliance. They do climate research right now. So those are all the different kinds. I think what's challenging is
I'm not actually getting the red dot, but one real quick.
Yeah, what's challenging, I want to say, is you basically need a very good platform for this. And so every technology development which we do will make it easier for every of these applications, which might be not commercially the most interesting one right away, not the lowest hanging fruit, but it will boost all these different applications having the right platform and right technology, and that's also what we as Intel do and want to support.
We got out real fast. Thank you so much, gentlemen.
Thank you.
Thank you.